How can we predict when a supervolcano will erupt? How big is too big for a volcanic eruption? And what would a global supereruption look like? So glad you asked these questions. Let's talk about supervolcanoes, which are volcanoes that have had eruptions with a Volcanic Explosivity Index, or VEI of 8. A VEI of 8 is given to eruptions that eject more than 1,000 cubic kilometers of material. The massive amount of material released in a single event is the key factor here. That much ejected material makes a huge ash cloud and a huge eruption column. These features are what define a supervolcanic eruption. But let's be clear, not all supervolcanoes erupt with the same force. In fact, there's a range of sizes within this category. 1,000 cubic kilometers may sound really big, but it's the low end of the scale for supervolcanoes. There's a 1980 eruption of Mount St. Helens in Washington State, USA, that ejected 3.6 cubic kilometers of material. The famous 1883 eruption of Krakatau in Indonesia ejected about 25 cubic kilometers of material. Both of these events were serious, but they were just barely over the threshold to be considered supervolcanic eruptions. On the other hand, the 1991 eruption of Mount Pinatubo in the Philippines ejected around 5 cubic kilometers of material. That is still just barely a supervolcanic eruption, but it was far more devastating than those previous two examples. On the other end of the spectrum, an eruption of 6,000 cubic kilometers or more gets its own special designation. We call these hypercolossal eruptions, but okay, so now we know how big these things are. Let's talk about some of the ways that scientists try to warn us before one happens. First, we need to talk about magma chambers. Many supervolcanoes have giant magma chambers below them. These magma chambers are formed by magma that has been slowly pooling beneath the Earth's surface for a very long time. Sometimes the magma chamber is connected to the volcano above it, but sometimes there is no volcano at all above the magma chamber. Instead, there might be just a small mound or even nothing on the surface that tells us there's this underground magma chamber. Over time, the magma chamber fills up until it's ready to erupt. Some magma chambers can take thousands or even millions of years to fill up, and some of them don't even fill up completely. It's hard to tell exactly how full these magma chambers get before they erupt because it depends on the magma chamber and the type of magma that's filling it up. However, once the magma chamber is full enough, the pressure starts to increase. Eventually, the pressure gets so high that it breaks through the Earth's crust and releases the energy that has been building up. This release of energy is what causes the supervolcanic eruption. So one way scientists try to warn us of an upcoming supervolcanic eruption is by looking for signs of a magma chamber filling up. They do this by measuring things like the local uplift of the land, changes in the area's temperature, and seismic activity. If any of these things change suddenly, it could be a sign that a magma chamber is starting to fill up. Another way scientists try to warn us is by monitoring gas emissions. When magma rises from deep within the Earth to a shallower magma chamber, it releases gases that have been dissolved in it under high pressure. This is usually the first sign that we see of an impending eruption. The gases can be detected using remote sensing instruments, and they provide a valuable early warning sign. The final way we try to warn ourselves of an impending supervolcanic eruption is by monitoring the volcano itself. If there is a volcano above the magma chamber, then there are many different things that we can monitor. For example, we can use seismographs to listen for the sounds of the magma moving inside the volcano. We can also use ground-based radar and satellites to look for changes in the shape of the volcano. And we can use gas sensors to detect changes in gas emissions. All of these methods give us clues as to whether or not the volcano is getting ready to erupt, and if it does erupt, how big the eruption might be. Okay, now let's move on to our next question. How big is too big for a volcanic eruption? Well, that's a difficult question to answer because it depends on what you're comparing it to. For example, the 1883 eruption of Krakatoa was pretty big. It ejected around 25 cubic kilometers of material and killed more than 36,000 people. However, it was nowhere near as destructive as the 1980 eruption of Mount St. Helens, which only ejected around 3.6 cubic kilometers of material but killed 57 people. This is because the location of the eruption makes a big difference. If a volcano erupts in a remote area, it's unlikely to affect many people. But if it erupts in a densely populated area, it could be much more destructive even if it ejects less material. So when talking about the size of a volcanic eruption, we have to consider both the amount of material erupted and the potential impact on humans. In general, a VEI of 4 or higher indicates an eruption that could be dangerous to humans. A VEI of 6 or higher indicates an eruption that could have global consequences, and a VEI of 8 or higher indicates an eruption that could potentially end human civilization. Now let's talk about what a global super eruption would actually look like. Well, it would start off with a lot of gas emissions and seismic activity. As the magma chamber began to fill up, the ground would begin to uplift. And then suddenly, with a massive explosion, the volcano would blow its top. The eruption column would reach high into the atmosphere, and the ash cloud would spread across the globe. Global temperatures would plummet, and there would be widespread crop failures. The skies would be filled with so much ash that there would be almost constant daytime darkness. It would be hard to breathe outside and even harder to see the sun. It would take years for the world to recover from such an eruption. But life would eventually go back to normal. Now I know that this sounds like a doomsday scenario, but these types of eruptions are extremely rare. There is no evidence that any major cities would be destroyed in such an eruption, but there would definitely be some serious crop failures and respiratory problems. In short, a global super eruption would be a disaster, but it wouldn't necessarily be the end of the world. One of the most important things to remember is that not all volcanoes are created equal. The explosivity of an eruption depends on several factors, including the type of magma, the shape of the volcano, and the amount of gas dissolved in the magma. For example, Mount Pinatubo is a stratovolcano. These are tall, steep-sided volcanoes that are made up of alternating layers of lava and ash. Because of their shape, stratovolcanoes tend to be more explosive than other types of volcanoes. On the other hand, shield volcanoes are wide and flat and they tend to have more effusive eruptions. Magma oozes out of the top and down the sides rather than exploding into the air. So, basically, it's not enough to just know that a volcano is there. We also have to understand the volcano and the type of magma it's erupting in order to predict how explosive the eruption will be. Another important thing to keep in mind is that supervolcanic eruptions are extremely rare. In fact, there have only been 3 confirmed supervolcanic eruptions in the last 10,000 years. So while it is important to study them and monitor volcanoes closely, there is no need to panic. The chances of a supervolcanic eruption happening in your lifetime are very slim. That being said, scientists do believe that there are more supervolcanoes out there that haven't erupted in the last 10,000 years. It's possible that some of them will erupt in the future, but it's impossible to say for sure. There are a few places on Earth where scientists are closely monitoring volcanoes because they have the potential to cause major damage if they were to erupt. For example, there is the Yellowstone supervolcano in the United States, the Campi Flegrei supervolcano in Italy, and the Lake Kivu supervolcano in the Democratic Republic of Congo. Scientists are monitoring these volcanoes closely to try to get an idea of when they might erupt again, if they erupt at all. And finally, it's important to remember that not all supervolcanoes are created equal. The explosivity of an eruption depends on several factors, including the type of magma, the shape of the volcano, and the amount of gas dissolved in the magma. Thanks for watching this episode of SCI Show, and thanks again to Brilliant for sponsoring this episode.